Hello and welcome back to another Island 54 development stream. So the last couple of days I've been working on improving the scalability of my services. And towards the end of yesterday's stream, I actually ran into an issue with the way I was doing UDP. Because I had broken up the UDP receiver and UDP transmitter into two different services, I realized that it wasn't going to work with NAT in the middle. And I don't know if I have my diagram handy. I seem to there's an issue in this tool I'm using for notes that's sometimes losing my diagrams. I will speak to the developer about that. Let's see if I can have that diagram anymore. But I looked at a couple of solutions at the end of yesterday's stream and decided the best option was going to be to put a proxy in front of the UDP transmitter and receiver, and that will let it. The issue is I need to make sure I'm always sending UDP packets from the same IP address that's receiving them. I tried getting Nginx to do that for me, but for a couple of reasons that was going to be too much effort. I've started implementing this proxy service just off stream, and it's obviously going to have some performance issues being in TypeScript. There's a little bit of processing that needs to happen, and TypeScript is not going to be able to take full advantage of multi-core machines with shared memory in between those multiple cores. So I'm going to continue developing this in TypeScript just as a proof of concept, but this is the kind of thing that would definitely be better implemented in pretty much any other language, whether it's C++, Java, Go. C++ and Go are the ones that spring to mind as the most appropriate for this kind of a service, this proxying service. I might as well just quickly redraw this diagram of what I want it to look like. We've got our 144p, I hope not, just having a look at that graphic. I hope it's not me. Just looking this up. Oh, sorry, I thought it was Graphic saying they could only see it in 144p. Yeah, this is definitely going out at 1080. Yes. So I have my UDP receiver service, I have my UDP transmitter service. Now, at the moment, UDP receiver is responsible for obviously receiving the UDP packets, validating the UDP packets, looking up the session data, and then decoding the data that's in that packet to convert it into a JSON blob that it can then go and process. It sends things off to the entity service, whatever. UDP transmitter, on the other hand, runs on a timer, and every tick generates a diff of between what it thinks the client can see and what it wants the client to see, encodes that into a protobuf message, and then it goes and crafts it into a packet with all the hashes and other stuff that the client needs to decode it and validate the packet. So these are both responsible for the security side of things, as well as encoding, decoding, and then the actual logic. So UDP transmitter, the logic obviously is generating those diffs. UDP receiver is really light logic at the moment. All it does is it passes them off to the entity service, but ultimately it will be responsible for doing a little bit of permission checking, making sure that people aren't trying to update a location of a troll, for example, at the moment, that you could send a packet that says, hey, I'm moving the troll around, and I'd accept those. Now, the issue arises, this is a bit of a recap for anyone who was here yesterday. When we've got the client over here, this is all fine because the client will send a packet to the UDP receiver, and then when we capture the port that comes from and the IP address it comes from, and the UDP transmitter goes and returns a message and sends it back to that same port and the same IP address. The issue arises when there's some sort of a NAT sitting in front. And the problem here is that the NAT will obviously change the IP address because this is going to be like 192 dot whatever or 10 dot whatever. This will then convert it into a public address. It will also change the source port. Now, when the UDP transmitter sends something back, the NAT will not know what to do with it because it will have the correct IP address and port, but because it's come from the wrong location, the address translation will probably not forward that packet onto the client. So the fix for that is to put a proxy in front of here. And just pop there. And it what will now happen is when the client sends a message, it will go to the proxy instead. I do that, kind of. There we go. That will then forward it on to UDP receiver. And then this other end will then come in like this. The only requirement here is that we need to make sure that a single instance of a proxy is serving an individual client. Now, that's not too bad if all this thing is doing is the communication side of things, as long as it's not doing all these complicated, the transmitter is doing all sorts of horrible diffs and things, which makes the scalability quite difficult. We need to be able to spin these things up and down really quickly. Whereas these proxies, one single proxy, it's well written, could handle a lot of connections. Now, we can probably be a bit smarter and do more than just literally proxy the UDP traffic through. What we can do is we can do a little bit of security stuff on this proxy service as well. So that's what I've started doing. The big question I have is whether or not I also do the protobuf on the proxy server. And while my gut says that I shouldn't, for simplicity, I am going to do the protobuf on this side as well. Now, it means that the UDP receiver is going to become really small for now. It'll still have to do its authentication, its validation later. UDP transmitter will stay, pretty CPU intensive, doing all its diffs. But I think that this is a pretty good architecture. So that is what I started working on yesterday, off stream. And that's what I'm going to continue on now. Now I've got a few comments that I haven't responded to. Can load DLLs into TypeScript. Yes, I can load DLLs into TypeScript. And that would at least let me get around the shared memory side of things. At the point that I've done anything in C++, I kind of feel like the rest of this is pretty straightforward, and I might as well just do the whole thing in C++. Or I think Go is well, I've never actually done any Go. Having seen systems like this being written before at previous employers, I've seen some pretty good results from Go on things like this that are really just proxying. Yep, then the quality stuff. Try to write notes in the dark. Yes, I can imagine that handwriting in the dark wouldn't be good. Okay. So, just to show what I've done, I've taken a whole bunch of code out of UDP receiver, UDP transmitter, and plonked them into the session service. Now, this is not what I showed in my diagram. But again, this is just for the point of keeping things a bit simple to begin with. The session service at the moment doesn't really do much. So there's no reason I can't actually make this the session service. It gives me a couple of benefits for now. One is that a lot of what the session service needs to know, it is things like the address that it's going to contact the client at. It's also things like session keys and session IDs, things like that. Now, for the most part, those pieces of information like session keys are only needed by whoever's doing the validation of the packets. Same with IP addresses. They only need to be known by this service. They also only need to be known for the lifetime of a session. And sessions themselves cannot migrate between instances of whatever this service is. So my logic there is I might as well just keep a lot of that information just in RAM. If this service goes down, all of those sessions are going to have to get built up again anyway. So there's no benefit to storing them in Redis or I think session service uses Redis. The only information we do need to store in here are things being used by UDP transmitter, which is the client state is something that's fairly large being stored up here, and also we'll need to add into there the specific instance of this service that needs to handle the session requests, so that the UDP transmitter can connect directly to the correct proxy. So this is a bit of a hack, the fact that I'm doing it in the session service. Yes, this would be better to break up into two services, but this just keeps the refactor a bit simpler. I can break it out again later once I've done the structural change. Okay, so what have we got? Just got to remember where I was actually up to. That was, I think, the biggest preamble I've done on one of these streams. So we can see we've got the UDP session data. This is just our in-memory information. So we've got the session key, which I don't think we're using yet. We've got the remote address. And then I've got some exported functions. So we've got register session. That will happen whenever a new session is brought up and just allows it to store the key that's going to get used against a session ID. Delete session needs to happen whenever a session goes stale. And all we do is we delete that entry from the local in-memory session table. Process datagram happens whenever preambles are good for making videos. No, yeah, potentially. That's probably actually a good idea for me to go through the preambles because it will give me a good summary of what I've been working on each day. Process datagram will happen whenever a datagram comes in from a remote host. This is mostly the same as it was before. I did find a slight security issue that I've fixed. It wasn't massive. It would potentially allow someone to prevent sessions from coming up just by spamming badly formed packets at the server. That's been fixed now. All we do is we read out each of the fields from the datagram. They're just the control word, which tells us how to interpret this data. Session ID, pretty obvious. The hash, this will ultimately become a signature of some sort. And then the actual payload, which is going to get converted, well, it'll get interpreted as protobuf. We look up the session from the session table. If we don't have that session, then there's nothing we can do with this packet. It's probably been sent to the wrong proxy, or the session has gone stale and then suddenly come good again. There's no point in us doing anything to try and handle these packets, so we just drop the packet if that happens with a warning. If we do have a session and we have stored information about the remote, we can make sure that the session is still coming from the correct location. This just protects a little bit against people spoofing packets. It's not perfect, but it just gives us that first layer of protection. In the event someone's internet, switches from one provider to another, someone switches between wireless and wired or something like that, this will cause sessions to go down. I'm not concerned. The system will come good again. This is for future when we start actually signing packets. At the moment, I just use CRCs. We make sure the CRC matches. Then this is the thing that I changed from a security point of view. This used to happen at the top. All this does is says if we didn't have the remote IP address, then store where that IP address is coming from. This used to be up the top before we had validated the other information, so this just makes it a bit harder to spoof packets. So what I don't have in here is the code to fuzz payload as protobuf. And I have been umming and ahhing about whether or not I keep that code in, whether I put that code in here or leave it over on the UDP receiver. My protocols just become simpler if these services are passing JSON between each other, so I'll leave it as that. And then we also need to do hand off the message to the UDP-RX service, which is now terribly named because it doesn't handle UDP. It now handles JSON. Over on this side, over in the server coming up, it now creates a listening socket. Presumably we just process datagram. So every time we receive a message, it just passes it off into that method. That's fine. It listens on... Oh, I'm so sick of that spam. You guys on YouTube will have probably not received that. Hopefully YouTube blocked that nice and quickly. Nope, they didn't. Let's just clean those up. Okay. They're gone from there. I'll just quickly get rid of them from Twitch. Yeah, they should be gone now. I just need to get rid of them from Twitch now. Oh, I need to not use the ban button on Twitch, otherwise it'll ban restream. Okay, let's go delete, delete, delete. There we go. All right. That should now be mostly cleaned up. Yeah, I've had some of them pop through yesterday as well. I might have to turn on the... there must be a way of turning up their filtering. YouTube's terrible on spam detection. I don't know why they're so bad at it. All right, well, that was a distraction. But yep, here we go. So we bind on the port, and that should be everything needed for the UDP receiver. We do need to configure Express because we still have the sessions endpoints on this service. We need to, well, I'll just bring up my little to-do app here. I've got a few things. We need to change sessions controller to call into datagram service. We need to finish off the implementation of process datagram. And we also need to implement transmit datagram, expose endpoint for transmit datagram. Okay. So let's get to these in order. Change sessions controller to call into there. So this will be a fairly major change. So it used to store a lot of data against the, it used to store it in Redis, I believe. Or is that, well, here it's putting stuff into the entity service. That's fine. It needs to create the actual player. Let's go through this in order. Yep, here we go. We call off into Redis and we send in the session ID. We store the player ID and time registered. Now that stuff can all sit in, player ID has to sit in Redis. Time registered, because that's of interest to the entity service, the UDP transmitter, that definitely has to sit in Redis. The point being that those other services should be able to just call into the session service without caring about which instance they hit up. Should be able to call into any of them to extract that information. Time registered is used for timing out connections. That does not need to be on any of the other users. This is all internal. So let's move time registered into the, sorry, trying to talk and think at the same time. I'll move that up into this type. Let's just call it timings. Must have a timing structure. First one is going to be registered, which is going to be a number. Now, when a session gets registered, here we're making sure, well, TypeScript effectively making sure that that timings registered is on here. That's all good. So we go and hit that up. We then create the player object. This involves a call out to the entity service. We build up some more session information. Slightly surprised I keep this kind of stuff on the section. I actually think this is a little bit of a bug. This is information we're expecting to go back to the user. So I think that that should actually be something like this. Config with that. of type that is not assignable. Yeah, okay, so there's some typing information that's going to have to be updated there. Entity ID, I think we had already... Nope, that needs to go, that actually needs to go in. Invalidation acts. This will need to be handled by the transmitter because the invalidation information is all about how to... that affects how we generate diffs. So that is needed in what goes into the session Redis store. So that all stays the same. Yeah, we don't need to store the configuration against the session. That just needs to get sent back to the player. What we do need to do though, we need to store a little bit of stuff in memory. So in here, we are going to register the session. Welcome, random guy. It's continuing on yesterday's work of implementing that proxy. Not sure if you were there at the end of the stream where I realized I was going to have to implement a UDP proxy. TypeScript is definitely the wrong language for this, but this will just get me going. So we register a session. We need to pass it the session ID and UDP session data. We don't have a remote yet. The key, I'm just going to not sure if I can do that. And then timings is going to be registered, which is going to be now. So we just put a dummy key in there that will later get used for encrypting and decrypting data. We put it's all okay. Yeah, I'm not doing any encryption yet. Yeah. It doesn't like this because I presume my session definition it's expecting what's it expecting? It's expecting probably a registered time. Yeah. All right, so this is our persistent session. Can I actually, let's rename this persistent session. This is what gets stored and can be accessed by other services. We no longer need to know when it was registered or seen. We do need to know these IDs. Anything to do with acknowledgements will be needed by the transmitter service. This is all to do with acknowledgements. Remote, we no longer need the remote. And I don't believe we need this stuff. I'm going to keep it around because it does get sent back to the client. So I will just do that so that we have access to that type. All right, that should get this code almost compiling. Yep, fair enough. Let's make that create session response. And I will say, I think I can actually just make this a type and make that persistent session and config, session config. Okay. This code depends on our internal in-memory state. I'm not sure why this originally lived in the session code at all. What used to happen, I see why this is being done like this. The session service was being asked by the transmitter to enumerate all of its sessions. And what the session service was doing was it was going through, and if any of them had timed out on being established, so waiting for the first packet to come in, they'd actually get deleted at read time. So this code is going to have to move to the in-memory section, which is inside the datagram service. I'll just put that in there for now. You need this to be just a session ID. Oh, when I press the F1, I don't even know what button I pressed just then. Oh, I've got a browser button up there. Then in here, const session. What did I call them? UDP session data, session ID. Jumping around a bit here, I need to add the registered time and the last seen time. Session dot timings dot last seen session dot timings dot time registered. Go. Moment, at moment. Yeah, absolutely. Welcome, Formal Goose Foundation. Welcome to the stream. Currently writing some hacky TypeScript code that shouldn't be done in TypeScript to pass UDP packets around between backend services on an MMO. Okay, so this checks whether or not, yes, it's valid. If it works, that's one thing. The problem is this is going to be a very, very, very high throughput service. And my normal logic on these things is to spin up more instances, but these particular ones affect the way that connections work. So these ones cannot be easily spun up and down, unfortunately. So this will need to be rewritten, but the point is just to prove that the rest of the system is scalable. Okay, so what this will do, this function here just is able to tell whether or not a session should be timed out. Termination. It's not. Have I seen what you Unreal Engine users have to go through? Yeah, there's a definite art to writing good C++. It is a very different language to many other languages. Can be done. Definitely be done. Although I've not actually played around at all with Unreal, so I don't know what the integration into the engine is like. Okay, so that is that code moved. I don't look like I was ever calling that, was I? Okay, report citing definitely shouldn't exist in here. So what used to happen is the UDP receiver service used to receive a packet and it used to call out to the session service in order to say, hey, I've seen this session. Can you please update all your timings to stop the session from timing out? Now, given that those packets are now coming directly into the session service, that can also move down into this class or this module. Const report citing is, I'll just make that an async, something like that. We need proto. Where does proto live? I'll just do this directly here. Why shouldn't you write with a dull pencil? So, don't know. Why shouldn't you write with a dull pencil? Random go. Okay, so let's port this code across. I'm not going to call this report citing anymore. I'm going to call this record citing because it's pointless. I like it. The right tooling. I like that one too. Knowing software developers, we could probably try and find a way of sharpening the pencil with a hammer, just for fun. Feels like what I'm doing here, writing a UDP proxy service in TypeScript. Okay. Let's get rid of proto. What this code does okay, this is a slight issue. So this code here is storing some last server ID act is getting pushed into the session storage. So that's going to have to happen in here somewhere. process datagram, parse payload as protobuf. To do, update act data in shared store. We need to strip out just a couple of bits of protobuf and push them out into Redis so that other services can see them. Welcome back, MetalStorm. Getting a good showing in Twitch today. We don't often get many in Twitch. Okay. Well, I guess that if I probably, that last to do I just put in there probably isn't all that important, because I should be able to, this is all still just part of recording the sighting. So perhaps I really just want to call record sighting. Let's do that. Record sighting. We need to give it the session ID. That needs to change to be session ID. Excellent. And then what, I just pass the client message. Okay. Through this code again. So we check which message the client has acted most recently. Server ID act last. Client ID seen? That shouldn't really be last. It's just the current one. Why I called that last client ID seen. Invalidation act. Yep, we need to know who's being act. And then we need to make two calls in here. One is going to be out to Redis, and the other one is local. So first I'll do the local one, which is going to be the UDP session data session ID .timings .last seen. It's going to be moment value of. Oh, what did I just do? Those. Then I need to store this data here in Redis. So we should have a report. Oh, no, of course we don't have a report. Slash sighting endpoint. Here it is. So this endpoint's going to disappear. Let's just get rid of it now. We no longer need that endpoint. This code is all going to come down into this other class, into this other module in a roundabout here. Assistant session. So we'll just do that as a rename. We're going to fetch the session ID. Now, of course, all of this can be asynchronous, so I need to make sure... Oh, yes, this is asynchronous. That's fine. We'll just need to make sure we don't await on this, because this could be quite a slow function. Don't want to lock anything up. Oh, well, yeah, it doesn't matter. TypeScript. We'll just end up getting more requests in and processing them in parallel. This is all fine. If we don't have a session, then and there's nothing else we can do here. If we don't have a session, then we need to... in fact, we should probably be throwing at this point, right? Am I going to be streaming tomorrow? No, I won't be streaming tomorrow, random guy. Weekend for me here, and my kid's first day of holidays as well, so I think I'd get in trouble if I were to work tomorrow. I probably need to throw, because if this fails, then there's nothing, like we don't want to process a message if we don't have any persistent data for it. So what I'm going to do is I'm going to move this up to the top. Very first thing I do is make sure that throw new, how do you throw exception? I can't remember how to throw an exception in. I'll just throw an error. Okay, so yeah, if we couldn't find a session in Redis, then there's nothing we can do. We'll have to catch this higher up and just drop the packet. That is all good still. Then time last seen, we don't need to set. Last server ID act is going to be last server ID act. ID is client ID scene. I see why I originally called that last client ID scene, but yeah, this naming's better. Validation X. No longer need to do that post. Tempted to collapse a lot of this. Nah, I'll just leave it. Sessions controller.update session. Oh no, that was right. We do want to use the controller. This is a terrible name, sessions controller. Oh, lost some code, I think. Oh, there it is. Update session, persistent session. Sessions controller. This isn't really a sessions controller. This is some sort of a Redis service. So that'll need to be renamed at some point. Don't need to do that. I will wait for the response here because that's how we know that the citing has been recorded. If the caller to this doesn't care, then it can not wait on the promise. All right, getting there. So I said I didn't want to await on here, but I think it's safe because record citing, yes, it's slow, but that just means we'll end up with a lot of instances of this process datagram running in parallel, which is absolutely fine. Yeah, we kind of don't want to. I'm sure this isn't the best way of doing this, but when all you have is a hammer, which is my knowledge of TypeScript, about it. The point here is that we can safely hand off the message to the UDP receiver service while we're recording the citing. Those two can happen absolutely in parallel. In fact, I will swap them around. The UDP receiver is ever so slightly higher priority. We'll wait on that. All right. Completely untested, but what were we working on? I was changing the session controller to call into the datagram service. Okay, disestablished session is going to also call into the datagram service. I've got this other method called, find it, to select register session, delete session. Oop. It's bad naming. Okay, this wants the ID. I have session ID. Now there is a bit of a race condition in here. Let's just those with ID. If we delete the in-memory session before we delete the persistent session, then other services might think that this session still exists when it doesn't. But if that happens, then once a packet gets back into this service for dispatch back out to the client, it will get dropped because we won't have any session data for it. We won't know where to send it. And so this will be eventually consistent, which is fine. Fetch all. So this part just here is responsible for terminating expired sessions. We don't need to do that anymore. But I do need to port that code over to the datagram service and do an export const. I'm not entirely happy with this. Bonus points if you can work out why I'm not happy with this. So what this is going to do is it's going to go through each of the in-memory sessions. Object dot entries. Turn that return ID section data. Okay, so I can do I need brackets around that, don't I? Now in here, I can then say if as establishment timed out, this should actually be called has session timed out. I can simplify this by just doing keys. This then just becomes ID. Go. So if the session has timed out, then controller dot delete session by ID. That will clean up both the persistent and the non-persistent sides of things. Now the issue we have here, this needs to be in await. The issue is that if something does, if I have an instance of this session service that goes and creates a session, it's going to put an entry into this in-memory table. It's also going to put an entry into the shared table over in Redis. If we call this disestablish stale sessions once every few seconds or whatever, then that will clean up stale sessions. But the problem is if one of these services goes down, we'll end up with orphaned data sitting over in Redis. That is not good. And I need to somehow record that. Like I need to be able to find those stale sessions. What I'm going to do for now is, because I'm sort of 3 or 4 layers down this stack of to-dos, I am just going to defer this one. Handle orphaned assistant sessions that could end up in Redis. Yeah. So I can call this method every few seconds. That's fine. That will just kill any old sessions. Actually do that. Easiest way to do that, I think I've got a tick function. How do I define a tick? I don't remember how I do this. There's a frequency and an on-tick. Cool. So let's just give it a frequency of 1 and an on-tick of disestablish stale sessions. Right, once a second, this will just go and enumerate its sessions and say, hey, if they've timed out, then just get rid of them. Stale sessions probably aren't the end of the world. Probably only need to clean them up. Like, doesn't matter if we do it like once an hour or something like that. If these services are crashing really frequently, we've got bigger problems than orphaned sessions. But we don't want them hanging around forever. All right. So I was working on migrating the sessions controller to call across to here. How long will I be streaming for today? Probably another hour today. I think random go. Okay. So create session. It doesn't quite compile. That's because last seen is optional. That has all been done. Disestablish session. This is what should actually be called. From in here. What? Yeah, fair enough. That should be calling delete. And delete should be calling into this, I guess. No, this isn't right. Yeah, this is very, very wrong. we need to delete the session by ID, and then we also need to, I'll do it first, delete UDP session data ID. Of course, we can't do that. We need a return of that. Promise.all at await that. All right. So the issue I had there is I need to be clear who owns what data. So this service is responsible for the local in-memory version of the data, whereas that sessions controller is responsible for the shared data. This does give us an issue where if we actually call a delete endpoint, then we'll end up with an orphaned session going the other way. So we'll delete its entry from Redis over in here, which we'll delete by ID, delete it from Redis, but it will not delete the, sorry, that was deleting the player, but yeah, it'll delete the session data, but it won't delete the in-memory data because it might not have access to the in-memory data. That will mean that we might end up with some data hanging around longer than it needs to, but it will get cleaned up eventually. This is good. Okay, coming back through. So disestablish session, I think never gets called, and I don't actually want that. Yeah, again, the reason is the sessions controller could get called on any instance, so we may not have access to the in-memory database. Fetch all. I can't imagine this will change. All this is doing is returning the persisted sessions. Fetch. I mean, something that might be nice in here, let's do as a to-do. In-memory UDP session data, sessions hosted by this instance. This will ultimately mostly be a debug endpoint. And so it might be nice for the administrator to be able to see all the timeouts and things like that for sessions that happen to be located on the instance. Likewise, perhaps we should still be storing those timeouts in the Redis database. That would help with the orphaning problem. But we do need to store them locally because we don't want to have to look up Redis every single time a packet comes in. It's not ideal. Okay. We've got fetch, doesn't change. Update session, doesn't change. Rename it. Be clearer what it's doing. Delete all only deletes the persistent records, but that's clear. Delete persistent session by ID. Okay. Done. Finish off process datagram. That is probably pretty easy now. I need to do what the UDP receiver used to do. Grab this code in here. Yep, something like that. Okay. Then we need to pass that message off to, don't need the YAC, that gets handled down in report citing. Need to pass that off to the UDP receiver service. All right. UDP receiver needs to lose this entire class, and we really just need this line just here. Pull that off to here. I was hoping that would get interpreted as TypeScript. Got some feedback for the author of this. Cool. Okay. So this entire module can go. Does anything use control word? Yes, it's used all over the place. No, it's used by datagram service and also by index.ts. That's just a be there. Go. So I think I can move this into the session service. But I would personally rather it live off in my shared netcode or something. Oh, what am I doing? Let's just get this. How do I move it? Common netcode. Get up into there. Now there should be a file error. Code source. Okay. Something's not right here. What's this doing? Store remote. I don't think I use this anymore, do I? No, I no longer use that. Remove. All right. What am I doing? I'm getting UDP receiver. No longer needs this class. I get the feeling I have absolutely no code left in my UDP receiver. .ts. Surely this doesn't get used. No, that doesn't get used. Directory router does get used. This is Ah, this is a problem. Well, it's not terrible. I just can't load the UDP endpoint from the directory service anymore because that's now a property of the session. Because remember, going back to here, it keeps on losing my diagram. I have words with the author about that one. The client, when the client establishes a connection, we'll choose a proxy for them at that point, and they'll need to connect to that. But until they've created their session, which they'll do through this directory service, they can't. And why is this in the UDP receiver? I know why I put it here. I used to consider this the main entry point into the whole infrastructure. So this probably now belongs in the session service, which is now our main entry point. So let's put that one up in the routes. And then down in here, was I never calling into that anyway? All right. Down in here, let's give it a, that's meant to be app goes to, give it a session service app.use directory. I'll just put it on slash. That. Jumping around a lot here, I know. I need to change my Nginx configuration to map. If I do it, I think it's, I want to map slash, but not map other stuff beyond slash. Browser. Nginx station directive. I think it's equals. The equal sign is used to match a location block exactly as against the URI. Equals slash. Pass to session slash. Okay. So now when I hit up the main API server, if I go to slash, we'll get a directory back to tell us where all the endpoints are. If we go to slash sessions, that will come in here. UDP RX now has absolutely nothing in it. We no longer have this listener service or datagram processes. I do need to put a controller on it though, a router, to handle these incoming packets. So let's do configure express. Like that. Take this as an example to receiver router. That. Around random guy. Maybe see you shortly. I'll need a coffee pretty soon myself. Okay, so receive. This needs to be a post. Save. Really simple code. I got here app. That. Oh, that's comma or nothing. Come back and we grab this line of code just here. That is what we need to do when we receive a packet. We need to send updates like that. We need a session ID. Let's just throw that in here. It needs to be async. On here. I don't remember how these things. Oh, that's a class. So I just need to create an instance of it. Const entity client. All right. So all the receiver does now is it has an endpoint called RX with a session ID. All it does is it strips out that entity updates field and sends it off to the entity service. Now, obviously in here is where we do the validate the updates, which is a massive job. That's the thing that would prevent players from sending specially crafted packets that could do things like control the trolls and other players. Obviously, a big security exploit there. Then back on the session service, I need to contact the receiver service. Using this. I mean, my best bet here is just going to be to implement this as a REST client. Entity, not simple client. Pathing is a pretty simple client, so I'll just copy that one. And we will call it, I'm actually just going to call this RX. I'll ultimately kill off the UDP part of this name. That, yes, do that, async, receive message. Session ID. Services.rx. Okay, so we're not using Axios. That's why I couldn't get this to work before. I'm using other library because I learnt recently that Axios is turned into a pile of garbage under TypeScript. Turn client. We're going to post to RX. Oh, what was that? Oh, don't that. $, what that was about. Session ID, and then we just pass it the message. Cool. It's needed in there? I think it is. Okay, I'm going to need an RX client, which I'll define up the top. RX client.receive message to the session ID, and we just pass it the message. Just be a comma. Async. Yep, that's async. All right, I love it when the code kind of comes out nice and simple like this. Odds of this working are pretty remote, but be able to debug this. So I think that is the datagram processing finished off. Transmit datagram. Be a lot simpler now. Got all the infrastructure in place. Bit worried this code isn't getting used. I moved that somewhere else. Yes, that has been moved elsewhere, so that can be removed. Wow, I've got a lot of duplicated code here. Like this is not used either. I bet you this has been moved to the generate delta. No, not being used. Welcome back, random guy. You haven't missed much. Oops. The code for receiving UDP packets just kind of got really simple. Remove that function because it's apparently not being used. They're not being used. That's not being used. I should turn on a linked rule or something for dead code because I really don't like having dead code around like that. Construct server message. This is close to what I want. Turn delta, yes. So this is returning, yeah, there we go. It's returning an actual server message. Now, this is precisely what I want the UDP transmitter to do once I finish this refactor. So I want it to take the persistent session data, generate a server message, and then it'll hand it off to the session service to actually push that data out to the user. So where does this get called? Inside the datagram generator. So this entire function to do this drastically needs a refactor. I don't know why, it's not bad. I'd say that this used to have nasty code in it. So I'm going to take that entire method and port that over to here. So it was previously taking a persistent session and returning a buffer. Okay, let's keep that as it was then as a top level function. I'll rename it to generate datagram for client. This is going to take session ID and a server message. Don't add a type anymore. So I can get rid of that line. We're going to be constructing that packet directly. That comment is stale. All right, so we then encode the payload. We allocate enough space for the header. We then set the control word, which hopefully is coming from netcode. Yes, it is. Tell it not to encrypt. So I haven't implemented encryption yet. We write out the session ID. We write out the hash. I'll leave that comment in there. That's good for debugging. Probably put it behind a flag or something, but we write out that payload and then we return this buffer. Nice. Next. What it was doing is on every tick, it was going through every session. This will get refactored in my next stream because this is part of the fan out. And for anyone that's new here, the issue here is that if I have multiple instances of this service, then on every tick, they'll go through every session and they will generate packets for every session. So this needs to be replaced with something to go and fetch some of the sessions and just do it in a loop until all of the sessions have been processed by someone. So we take a session. We ask if it has a remote. I think I can get rid of this condition. It's a little bit of an optimization. This will prevent packets from being generated while a session is being established because we've got nowhere to send the data while a session's being established. But while that's a nice optimization, it's a bit of a pain to actually implement because that's private data to the proxy. I've still got another to-do item to put on here. Hold on. I am still not storing the so we need a way of making sure that the UDP transmitter sends this data to the correct instance that holds the remote information for that session. Otherwise, that packet will never get to them. It'll never get to the client if there's a NAT gateway in the way. So we grab our buffer. This is to generate the message and send it to the session service. Until I finish my game, it's really hard to say. I mean, having it in a state that I can have people testing it, I was really hoping to have that ready by now. I would like to think that I could have this in people's hands next month, but it would be there'd be none of this validation in there. Like, it would be possible for players to generate packets that could control whatever they wanted. So it would be fine for testing and things like that, but there's a fair bit of work that has to go into validating the packets. And the other thing missing is a lot of content. Like, it still has so little content. And so at some point, I'm going to have to work out how I'm going to generate enough content to make the game compelling. And so, yeah, I just don't know, unfortunately. All right, where was I? Back to here. Datagram service. Transmit the datagram. It is going to call I don't know, where's my socket stored? All right. Need to send the buffer. So let's do a generate datagram for client. Session ID from a message. Now, there's no need for us to generate any of this stuff if we don't have a session. So let's do const session is UDP session data, session ID. If dot session dot one. Okay, so if we don't have a session, then there's nothing we can do. Otherwise, UDP session, yep. Oh, dot remote, question mark dot remote. No, dot remote question mark. I can do one better than this. We can go remote question mark dot remote. Right, for session data or remote endpoint session ID. There we go. Now we're guaranteed that. So given a server message and a session ID, look up the remote endpoint for that session. Construct the buffer that's going to go out with all the headers and things on it, and then send that out on some socket. Unfortunately, here is the socket over here. So I think what I need to do is I just need to move this code into the datagram service. So we construct the socket. Something like that. All right. We now have a socket. Gets initialized when this module is loaded. As the server comes up, it'll tell it to listen on the port. I do need to tell this thing where the receiver is, not the external receiver. Oh, implemented transmit datagram. Expose an endpoint for transmit datagram. This should be pretty straightforward. I think I'll just put this on the session router. So this is the endpoint that other services, well, UDP transmitter can call into to actually cause a packet to get transmitted. It needs to, it's just going to call transmit datagram. It's going to pass it the ID of the session, and then it's going to pass the body. Why doesn't it like that? Oh, yeah, fair enough. Rename this one to transmit. I think that's all there is to that. Oh no, I need to set the res.status. Then UDP transmitter no longer needs to do any of that stuff. One moment, I just need to check the front door. No idea what that was. Catch around random guy. Yeah, I should be streaming Monday, I hope. So in here, we need to generate the message. I think I've got a method for that, which is just construct server message. just needs to know the session. I think I might need to try Copilot at some point. This is the kind of thing that apparently it is really, really, really good at. So just send it to the session service. All right, so I need another REST endpoint, another REST client, sorry, called TX. Yes, go ahead and rename it. Oh no, we don't need, this is wrong. Oh, I even renamed the wrong thing anyway. No, don't do this to me. Let me rename that. TX, I don't want a TX client. This is actually part of the session client. Async transmit datagram. Oh, Proto. Already got it. Yeah, I probably shouldn't. I keep on importing things from directly from within my source directories. I probably shouldn't be doing that. What I was thinking. Message dot client dot host. It's going to do something like this. I think there's an error in my RX client. Oh, that's correct. Yep. Okay. I no longer have a set remote endpoint. Session client dot transmit datagram session message. That needs to be in a wait. All right. Not sure why this never gets called. Well, this should never get called. This is binding to a listening socket or something. It's doing cancel that. Don't trust it. Yeah, so what I'm going to do, I'm going to see if I can just get this stuff compiling. I'm not going to have time today for proper testing of this. I'll try and get to that off stream if I get time for that. So let's see if I can just spin these things up. Spend a few more minutes. If everything happens to compile, then I will spend a few minutes trying to get things running. Okay, what was it? UDP transmitter did not come up. Why? Datagram generator has no export. Okay. I don't know why I'm not getting errors in here. Can I trick it to give me errors? There we go. That's got an error. For that. Yep, we don't need this. Ah. I think that we just don't really use this transmitter anymore. Let's just try getting rid of it, see what happens. That. Rerun. Hello, Selma, and welcome. I'm only streaming a couple more minutes today. I've been refactoring some of my services for an MMO after finding an issue in the way I was handling my UDP traffic. Okay, this was a really big change, so I wasn't expecting this to actually work first go. Oh, yeah, okay, so something is not working. What's it actually doing? Don't have session data or remote endpoint. So we have a session ID here. I wonder if framework. So the front end is in Unity and the back end is TypeScript. Might seem a strange choice, but it just makes for a very fast development on the back end. And the architecture I'm using allows for very quick scaling of the different parts of the service independently of each other. Do I have a client running or something? If I've got a client running, there's no way that will work. Yes, I had a client running. Unity is unhappy. So that should at least get rid of those errors. Nope, we've still got messages coming in. All right. Oh, given this was such a big change, I will. Sorry, that's. I'll bring down my database. Docker close down. Wipe away all of my persisted data and then bring it up again. So what I've been doing the last couple of days is just going through each of my services and making sure that they're actually scalable. And that's how I ran into my UDP issues, was in trying to scale the components that receive and transmit UDP packets out to the client. So this is looking fine. see if I can bring up the client. The odds of this working are not good. Sometimes Unity can be very slow to spin up. Skip that. All right. It is loading in chunks from the server. I appear to have no entities though. I'm expecting stones and trees and things to be appearing in here. Oh, we've got lots of errors here. Too many open files. That's not a good sign. Oh, yeah, okay. This is failing to create new sessions, talking out to the server. Not ideal. All right, anything over on the server side? Yeah, lots of stuff's broken on the server side. That is probably the issue. So we've got something wrong while it's trying to establish the sessions. Controller line 34. So the server is failing, trying to spawn the player into the world. Who's... Yeah. All right, I unfortunately need to finish my stream up here, which is annoying having it at such a bug-ridden time. I will be streaming again Monday morning Australian time, which is about midnight UTC, so Sunday evening US time. I may look into this off stream just so that I can see what, so I'm not sitting there just debugging frustrating stuff. But I won't get much of a chance to work on this stuff off stream other than perhaps a bit of debugging to work out where this thing's actually failing. All I know is that it's failing. It looks like it's failing trying to spawn the player into the world. So thank you everyone for tuning in. And I'll catch you all next week. Oh, hello. Hey, Griffic. Yeah, not a problem, Griffic. Catch you around Metal Storm. I will hopefully see you all next week.